Hello there.
With the ground beneath your feet, with a whisper in the trees. Do you feel us watching? Hunger in our eyes, victories on our minds. It's our time to rise. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. It's the calm before the storm. Things aren't as they were before. You best start bracing. Did you think you could keep us out? Shut the gates, forget us now. Tides are changing. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. Can you hear the sound? We're the revolution. With the ground beneath your feet, with a whisper in the trees. Do you feel us watching? Hunger in our eyes, victories on our minds. It's our time to rise. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. Can you hear the sound? We're the revolution. think of you and me. Don't wanna leave the world you see, and I will hold you
Hey everybody, it's Obi-Wan Pens for and Simplex Pachinko. As I said up there, I'm not going to be doing a whole lot of talking tonight because I've been coughing like the entire day, so I will not subject you to that. I'll try and just kick the microphone up if I need to. In the meantime, I've also been doing some work as a treasurer for my kids' parents and friend group. It's like the PTA, but, you know, British. We just did a Christmas fair on Friday, and we got a crap ton of 1 pound coins, because, like, you know, it's easy to say, sure, I'll spend £1. Especially when it's a single coin. So we ended up with a lot, and the bank only accepts them in 20-pound increments. So I have to put them in little baggies. So many baggies. For anybody who hasn't seen them, British pounds look like this. They have that bimetallic thing. And so the outside is sort of a goldish sort of color, whereas the inside is silver. This was an Elizabeth II from 2017. The back has like a nice little nice little seal that includes like the thistle, the thistle, which is the symbol of Scotland, the shamrock, which is the symbol of North Ireland, wheat, which is the symbol for England, or like, you know, the south of England, and the rosette flower, I'm not exactly sure what it is, which is the symbol of Yorkshire. And then there's like a few other things that are hidden in there, so they're pretty cool. And then I came across the new King Charles one, which I noticed the color is like so much closer. The bimetallic, or the outer ring, is like much lighter. It's much more closer to silver, and then the back has bees, I think. I can't really see that, but so it's pretty cool. But yes, 20-pound increments. And we have a lot of them. Oh, it's terrible. I'm trying to clear off the area where the tablet was going to go. It's just not even worth it anymore. Because, like, let's put it this way. We did pretty well. We ended up filling up this entire space in front of me. Granted, I do have a HOTAS that is sitting in the way. So we filled the entire area on my desk with stacks of 10 pounds. I was like, okay. Again, I am the treasurer. This is not my money. But just all of this stuff, really awesome. Gonna hit the bank when they open. Gonna go to the bank in the morning and hand in all this money. Let's be careful with our words. E-Curve. Good evening and welcome. Yes, so I have been living in the UK for the last year and a half, plus a bit. Kids have been going to school. Spouse has been working here. And, you really hate being treasurer. I mean, the good news is that I just didn't know what I was doing, so just... Yeah. See, I am not for our family, and I actually like that better, with me being the treasurer of other people's money, because then I feel like more responsible, I guess. Maybe that should be backwards, but I don't know. I feel like I have to be careful, right? Because, like, there are laws and stuff. Whereas if it's my family's finances, it's just kind of like, missing $100? Alright. Yeah, yeah. So, I mean, like I said, I think it's a little bit easier for me, for whatever reason, for me to be in charge of other people's money because there are stricter guidelines. Yeah, so, this is the thing I was balking at right here. You can put a maximum of 20 pounds in for 1 and 2 pound coins. 2 pound coins. I was putting them in stacks of 10, so I just had to pick up one stack and throw it in. I'm like, welp. Am I peeking? Are we getting too loud? I have to get a real microphone. Now, eCurve, are you affiliated with Exponential Idle in any official capacity? Oh, and this is the other awesome thing about UK money. I walked into the bank and said, I'm going to... Oh, I was just wondering if you were, if you belong to the Exponential Idle team, just because your username is eCurve, so probably not. It doesn't matter. Yes. Are you Gilles, for instance? Yeah, no. Anyway. So yeah, Exponential Idle is a cool little idle tapper type game. And anybody who's interested in checking it out, actually, let's not do that on that. Let's copy, paste into here. Anybody who's interested in playing, that has links for both iOS and Google Play. And there are other ways, I gather, to play the game, but I don't know. So, go out there and find it, I suppose. Basic idea is that you are a, like, graduate student who is trying to figure out how to go to infinity, and, like, you do all sorts of stuff to try and get to infinity, first by just tapping the screen, which does not work very well. We all know that. But then you get upgrades, naturally, which then cause you to move faster and get larger amounts per tap. And then eventually you can get something that automates the tapping. Of course, right? This always happens like this. Be it cookie clicker, be it idle, whatever, you know. pretty much everything with idle in its name has the same premise, right? You're trying to make number go up. Eventually, with exponential idle, you end up with numbers that get far too high to count. And so we end up with needing to or find a bug, yeah. Typically, right, the way it works in exponential idle is that you end up with numbers that go... Yeah, there we go, I knew it. Numbers that end up in the, 999,999 range, and then the next one that goes up is 1e6, so it automatically jumps to scientific notation. Hey, Famished, how's it going? And then with scientific notation, it's going to keep going up and up and up and up and up until eventually you reach, 9e99, I think it is. I don't remember exactly where it is. It breaks at some point, and you have to go to EE. Organizing your notes. Okay, yeah. Also a necessary part of, especially computer science. Java, Python, and C++. Nice. I have only ever edited C++. I haven't ever created a bit of code from scratch with C++. It was actually it was in grad school, and the task was to build something that modeled a particular situation, and I picked predator prey. Oh, it was do a modification of predator prey. And so instead of predator prey, which is a non-linear differential equation or system of differential equations. Also known as the Lotka-Volterra equations. Right, so x prime is going to be equal to alpha times x minus beta times xy. And y prime is equal to negative gamma y plus delta xy. So what this is, it's a system of equations, system of differential equations, which says that the alpha is your growth rate based on population. Okay, so this being the prey, for example, what's going to happen is that the prey ends up having exponential growth in their particular population. So in the case of deer, for example, if you just let deer run unabated through any sort of territory, they are not going to... they will eventually reach a carrying capacity, but more likely, you know, there's a few things that are going to happen faster than that. So rather than reaching the carrying capacity, which we'll call like, you know, up here, what's going to happen is there's exponential growth of the prey, but then we get this minus beta thing that happens after. Which is going to be the culling rate. Based on interactions. Between the species. So the predators come through, and they end up eating the prey, and so the prey species ends up losing population numbers due to their interactions with the predator species. Makes sense, right? Of course. And then we come down to y prime, and we have a negative gamma, and the gamma is going to represent the negative growth rate, or the slowing down So here, this is essentially the carrying capacity that I was talking about before. This is where the predators will end up reaching a maximum carrying capacity because they have too high of a population. If it was left entirely to just that particular term, it would eventually be a decay rate, so they would fall off and become 0. However, because it's not just up to the predators, there is also then the interaction between the predators and prey. Right? So the interaction between predators and prey benefits the predators. So, yeah, I really liked this section of nonlinear. And then what we did was we said, well, based on this, I decided to add scavengers. And so here we had z prime is equal to they'd end up having a, come on, they'd end up having an epsilon times z, and generally speaking, this is going to be negative. If it's just scavengers, they're not able to eat their own, in theory. They could, but we could also play around with the epsilon and see what happens. Then there is a positive interaction between I don't I don't remember what the next Greek letters are. Hang on. Yeah, it is zeta. Alright, zeta x Um, it's not, though, is it? There's something here that I went with. Okay, so clearly, zeta can be a benefit when x and y interact. Right? Anytime that x and y species interact with each other, there's going to be death. And so it was like, cool, let's throw that in there. And then I also did the death rates of both of the others. And I can't remember how I did it, but it was part of my project. Then I went and I said, okay, based on that, I'm going to build a something similar to a Cajonan network, which I learned in neural networks, where you're going to look at all of the individual pixels that are in this whole picture. First, they're randomized. However, if you look at any one pixel, right, what we have is an R value, G value, and a B value. RGB, 3 species, 3 inputs for visual light. So I was like, wow, this is actually pretty nice. So we can take any particular pixel and express its X, Y, and Z values as the values that are on the RGB scale. If it ended up being that all 3 of them happened to be 255, or any of them decided to start going negative, then we would just clip it to between 0 and 255. So there wasn't any, like, I wasn't allowing the values to go way far out. In theory, we could also, like, cut it down and say, okay, you can only, like, if a value of a certain creature within this area is above the limit, then, like, everything else can normalize down so that this is now within the limit, but then, like, everything else tends to get a little bit too close to 0, and, like, that's not really what's happening. So and realistically, that wasn't going to happen either because of all the other issues that were going on. There were a few instances where the predators ended up dying out, which was rather interesting. The prey would then go completely exponential and run amok. There is also the possibility that we could introduce, like, you know, a disease factor, which would be like, you know, eta YZ, and I closed it, lambda XZ, or something like that. You know, we could throw in all sorts of stuff. In terms of, I think the scavengers would always win in that case and then eventually go to 0. But the idea was to go through and start looking at the pixels immediately surrounding, look at their values, and then it would affect the values that we end up plugging into the equation. So it would end up, we would get one particular RGB value for the central square. So let's say it was this one. Then it would end up coloring the others around it, like more similarly to that color. Not entirely the same, but they would end up getting colored, you know, more similarly to that. And then the ones around it would, again, get a duller version of that color and a duller version of that color affected from whatever values they were. So let's say that one of these over here was, bright blue originally. What would happen was this would get trended toward this sort of duller color and end up probably somewhere in this range. Something like that. So I went through this whole thing. I explained it. The teacher for both the nonlinear and the partial differential equations class loved it because it was just like, well, I mean, that's this is how you do the thing. So good job. You know, the individual numbers were probably completely wrong because I didn't do that much research into, like, you know, what would we find for these numbers out in the wild in real life, because that's going to be hard. You know, you could call up the Game of Wildlife and see if they have a similar model, see if they have data, and possibly see if they would be interested in using this model to predict something. But, yeah, there wasn't really any involvement there. But could have been cool. Okay. With Exponential Idle. Anyway, oh, right. The reason for me bringing this up in the first place, so I found a little, like, Cajonan network modeler that somebody else had made, and it was in C++. And I was like, I don't know how to code C++, but sure, why not? So I just kind of, like, cracked the thing open, started playing around with the internal parts, and then recompiled it and ran it. And it worked reasonably well. I've actually run it on this channel before, back when I was in Maryland, so it's on the other computer. And I'm pretty sure it does not run on Linux because it's an exe file and it would be very unhappy with me. But there is a way to do it. It's just, it would stress me out. But yeah, this was all in C++, and I managed to rework it to do what I wanted, and then showed that off. So there was it was also much more fluid, so it would put down the color based on the distance away that something is from whatever one you were selecting. And I kind of ham-fisted part of it at the very beginning. I was like, it's just going to turn this color, and it turned, like, the entire circle around it was just like, it's this color now. And I'm like, that's not what I meant. So ended up working out that if we're going to do this, we can figure it out by radial distance and then change it by that amount. So it was pretty interesting. Or, like, percentage-wise, move it to that color. Alright, so for Exponential Idle, again, you get into 1e6, 1e99, and then instead of 1e100, I think it jumps to EE. Simulations with C++. Yeah, so because it's object-oriented, it's easier to make a lot of that stuff happen. It's always going to be a little hard, but, you know, you do what you can. Okay. So, in Exponential Idle, this is the basic premise, right? You're a grad student, you've got, or a postdoc or something like that, and your advisor is asking you all sorts of questions about how to improve the speed at which you can increase to get to infinity. Basically, once you get a few layers up, the system says, like, you know, it's time that you graduated, you got your PhD, congratulations, all that. And then now you're a postdoc, so now you have to have students who are going to be the ones who are doing a lot of the simulations for you. And so what happens is you now have students that you assign to theories. Right? This right here, this is your prestige currency. Or I guess it's called the, not prestige. This one's the supremacy. The prestige currency is called mu, and I don't remember exactly what mu is supposed to be, but yeah, it allows you to buy permanent upgrades. And so you can get like exponents on your values. You can get factor upgrades. So like the factors that you are buying every time don't increase by 1 or don't like multiply by a single number. They start doing all sorts of other crazy stuff. You can also buy X's. So basic equation f of t plus dt is equal to f of t times e to the b x sub n phi rho tau dt. It's like, this is a lot of stuff, but it's not a big deal. More or less, what happens is your x sub I is going to be equal to, on every step, x sub I plus, written in programming, x sub I plus x sub I minus 1 dt. Alright, so your dt is increasing as you purchase it. Your tau is increasing as you're doing other theories with your students. dt is your step size, which is not surprising. Let's see. Alright, student guided theories. This is like... research values from student allocation. Alright, your B's, our X's are here. And B is a good question. Where is B? Like, it must just be a constant. Oh, wait. Yeah, okay. B is based on... B is based on the improvement that you've made from the last publication of research. Right? Your mu, your prestige currency, is publishing. So the amount of improvement you made your score when you publish and then reset is going to then give you bonuses on like how close to infinity are you getting. So right now, my current publish level is EE 103 400. So I believe this is 10 to the 10 to the 103,400. I could be wrong about that, but I think this is what that is. And I think you can only ever get two E's. I don't think we do 3. I mean, clearly, right, we should in theory already be on 3 E's if we were doing that. Unless that's going to roll over at 1,000,000 of these points. Like, that's not even remotely possible as far as I'm concerned. Let's see, there's also some stuff in here about, like, other particular values, but we're not going to get into any of that. Yeah, this is graduations of students. So basically, like, you help an undergrad graduate, and then it resets everything, and they join your team, and then you start the publishing all over again. It's not realistic, of course it isn't. Alright, at some point, you're able to unlock student theories, the student-guided theories, which is where you get your Tau from. This is research, not theories. Alright, spoilers if you want to play the game, but it's not that bad. At some point, you end up getting theories where your total Tau that you get to turn in all the way at the top is going to be the product of all of the individual theories that you have activated. And these are going to be official. And you get 1 plus Tau sub I. Typically, Tau is in the range of, above 0. But mine currently, after playing this game for a long time, are all over E500. So plus 1 is going to do nothing. But it's just to make sure that nothing is 0. Right? It's going to be 1 plus. Everything is 0 until you work on it. So always going to be a 1 until you've done literally any amount of work. Okay, so there are... Why don't we just go through the individual theories and you can get a sense for what we're doing here. Right, so I'm currently working on logistic function. Tau sub 5 is equal to the max of rho. Rho is like the temporary currency value, and every time that you publish, every time you publish, it resets back down to 0, and then T5 has already collected that max rho value. So then rho drops down to 0, your max stays where it is, and then you climb your rho back up again. And rho dot is equal to, I know they use physicist notation, Q1 to the K times Q2 times Q. And Q dot is equal to C1 over C2 times Q times C3 to the M minus Q over C2. Okay, so what we're doing in here is we're looking at this. It is sort of a system of equations, but it's nested in this particular case, right? Q dot is really only just affecting Q. which is also a part of the second one, right? It is a it is an implicit function. Okay, so what we can do is we can purchase C1, which is logarithmic. So there's a logarithmic increase in C1 for a, I believe, exponential increase in purchase value. Logarithmic gain, but exponential cost. C2 is an exponential gain. And almost always, like our number 2 purchase items are almost always going to be exponential gain r equals 2, like almost every single time. And an exponential cost. The exponential cost on C1 is always a low R value, so it's like, 1.2 or something like that, that it's just going to increase like that. Oftentimes it's not particularly obvious. C3 is also, yeah. With a large cost increase, which could be exponential, or it could be bigger than that. Right, so the greater means like it's of a different order. So linear to polynomial to exponential to tower are increases in order. So they are no longer going to be just like, oh yeah, it's like bigger than the other one. No. It's like so much bigger that there is no possible way for you to always have a linear function that is going to outpace an exponential function. The exponential function will always catch it. So in this particular case, right, our cost increase will either be exponential or it will be of a higher order such that it will always outpace an exponential. All right, and then there's Q1, which again has the same like logarithmic gain with a small exponential cost increase. Q2 again is going to be exponential gain with almost always r equals 2 and exponential cost. So people were able to find through running simulations what the optimal behavior is in order to purchase this. So when you first start out, it's just basically click the screen a bunch and see where it takes you. the goal, or the local goal, is going to be to maximize rho dot. And like, no matter what function, no matter what theory, no matter what anything that you're doing, pretty much this is what you want to do, right? You want to maximize your rho dot forever. And obviously it's not going to keep working like that, because you've got stuff that is going to get you to gain slower than whatever the cost was. So you can't keep upgrading it. It's just going to get outpaced. Your gains are going to get outpaced by your cost every single time. It's only a matter of time. It might take a while, but it's only a matter of time. So, optimal behavior ends up being that you pretty much just always purchase Q2 and C3, no matter what. Which does make sense, right? Your C3 is here. It's a positive value. It will keep increasing your Q dot no matter what. Your C1 is also something that's going to be a good idea to purchase, but at the moment, right, it's not doing a great job. It's going to get quickly outpaced by its cost. And so it's going to have diminishing returns as you keep buying more and more levels. Doesn't really help. But Q2 and C3 are just always purchase, no matter what. It'll always pay off. Right, so hey, famished. Got some right here. I wish I could pass it to you, but, you know, you wouldn't want it. I'm sort of sick. But then what do we do? Too much math I got, and he's like, nah. False. Okay, so always purchase C2, Q3. No question. Initially, get Q1 at 1/15th the cost of Q2 cost. So the way in which it grows is telling you that, you know, if it ends up being if Q1 ends up being 1/15th the cost of Q2, then it's worth it. Just keep purchasing. Purchase until you get to that 1/15th price. This is stuff that's like not super easy to do in your head always, but like most of the time you just look at it and you go, okay, is it more than 10 times in the case that I have, right? I have E some number as the cost. So is it more than 1 down? If the answer is yes, then I just keep buying it. until it is, one E1 below whatever Q2 is. And you could also go like or C3. That ensures that you're going to get the doubling multiplier if you do that, right? So just always go with Q2 and C3 because you'll double your rates. And that's way better than a lot of the other stuff you can do. All right, then on publish, by C2 in maximizing groups. All right, what is that supposed to mean? Well, if you increase C2, what happens, you'll notice, right, C2 is going to decrease the speed at which Q is going to rise. It is also going to effectively double the carrying capacity of the logistic function. So instead of going like this, it's going to go like this. Half speed,
sometimes creating an ad campaign can feel like you're
double the height.
Sorry, we can't hear you. Say that again.
But advertising on Spotify.
All right, now it doesn't always work like that, but
With our easy-to-use ads manager, you can create new
it
audio
works out
from scratch.
approximately like that. So what you do is you try to purchase right about here.
It's that simple. Learn how Spotify can add more to your mix at ads.spotify.com.
Or maybe right here. Because what that's going to do then is it's going to put you here. Which is already on the upswing. It's going to get you moving quickly. Right? So then you still have, and in theory, right, you are still around the area of like maximum increase. And then what you do is you click a whole bunch on C1 and Q1 and Q2 and C3, just like get them to like auto buy basically, and then you wait until it starts increasing again, and then you hit C2 again. And then you're back over here again, and then you increase the height of the new version. You do all sorts of stuff. It gets the thing to be bigger, and then you're on the increase again, etc. All right. Ads are going to start here, so come back in 3 minutes. Everybody get up and stretch and go get something to drink or what have you. We'll be back. Thanks for coming. Alright. So, when it starts getting really high, then there's also a multiplier. Which gives you a bonus to subsequent runs. This is not surprising, right? It's the same as all of our prestige currency stuff that we were talking about up above. So this is your multiplier for this one is going to be equal to the number of students that are working on T. That's the total. Okay. The total number of students you have divided by 20 all cubed times tau 5, which is the maximum row currency value you have for this particular theory, raised to the negative 0.159.
Sometimes creating an ad campaign can feel like you're
Oh.
talking on mute.
Oop.
But advertising on Spotify
Ah,
is different.
it is not a negative.
We'll help your business turn up the volume and reach an engaged audience that's ready to hear and see your message. Learn how Spotify can add more to your mix at ads.spotify.com.
T tau 5 bar is the
When your kid's favorite toy starts to run out of battery power, no need to worry. Your new batteries are already on their way, arriving today with Amazon Prime. Everyday essentials delivered fast. It's on Prime.
I'm Professor Huggington, and I like to hug.
Cut-off times and T's and C's apply. See Prime.
last publication value. So the last time you published for this particular theory, that's what goes back in. So it doesn't talk about, or it doesn't give you any bonus for like the current tau value. It just talks about when was the last time you published. That's like the minimum bar that you have to reach in order to start getting higher multipliers in the first place. So, makes sense. And then there is a optimal. There is an optimal M value for every single different theory at every single tau value that you have, or every single row value that you have. And there's a nice calculator that does all this stuff for you. Okay. I'm not going to go through all these, so I want to get on to the lemmas, which I think are going to be a bit easier to actually do calculus on and like figure stuff out. It's pretty cool. Okay. So, yeah. Alright, so Season 5 are custom theories. And in this particular case, They're actually lemmas. They're like miniature proofs that you stick into a particular larger proof or something else that's going to help you understand the math better for those particular things. So what we have, we have a target of rho equals 1e10. This is a tiny number, and this is also a thing about lemmas. In the field of proofs, lemmas are usually pretty small stuff. Okay, so in order to prove lemma 1, we're looking for rho dot equal to C1 parentheses, C2 parentheses, sine of Q plus 1/2 plus C3. And Q dot is pretty much exclusively going to be 1 for like all of the lemmas. I currently have a record of 1700 seconds, or 1769 seconds. So if we expand this out, we might be able to see some way in which we might be able to find like optimization. So with that, if we go with right, where is rho double dot? What is rho double dot? Okay, if we look at this from an expansion, this is going to be C1, C2, sine of Q, plus C1 over 2, plus C1, C3 as a constant. Right, so then what is this thing going to do? Now we already know that this is going to increase the center line. Right, and C1, C2 is going to be the increase of amplitude. Now Q is also going to be, as it counts up, Q is going to cause the sine function to become both positive and negative. So it will have some impact on dragging rho dot back down a bit. So this is one of those things where, like, we want C1, C2 sine of Q is going to be less than C1 over 2 plus C1, C3. Realistically, C1's not even a part of this. C1 is just going to C1 is just going to increase the whole value. So whatever we get, right? Don't even need C1 here. Okay.
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again.
But advertising on Spotify can help your business turn up the volume.
So again,
Easy-to-use ads manager.
same as before, and in fact, this is even worse. C1 mostly just counts.
To an engaged audience that is ready to hear and see your message. It's that simple.
And so like
Learn how Spotify can add more to your mix.
C1 dot is going to be approximately 1.
Sometimes creating
Or
an
at
ad
least
campaign can feel
for the
like
most
you're
part.
on mute.
Sorry, we can't hear you. Say that again.
But advertising on Spotify can help your
C2 is going to be exponential.
Easy to use ads manager. You can create new audio ads from scratch or repurpose existing video assets. Then we'll deliver your ad to an engaged audience that is ready to hear and see your message. It's that simple. Learn how Spotify can add more to your mix at ads.spotify.com.
Alright, this means that C2 dot is going to be 2 to the K2, right? Whatever level you're putting in to C2. That's where we're going to end up getting here. Times the natural log of 2. And C3 is 2 to the K3, all minus 1. So here C3 dot is going to be the same, really. It's 2 to the K3 times natural log 2. We could go in and also look at like what the functions are that govern the costs of everything. And that could be interesting by itself, but that'd be something that I would want to plug into a computer program and make it do that. I don't know how to program this offhand. I probably could do it. Whether through like creating a spreadsheet, which would be absolute murder, or I did actually. Ooh. Oh, I don't know what that is. Hmm. I thought they encoded it less, less complicatedly. But no, alas. It seems it is just a hash. So, if we went with this as row double dot, then we could get this as C1 prime times all that same stuff. Plus, let's use that one over there. Let's use this one over here. C2 prime by sine of Q plus C2 by cosine of Q times Q prime, which is 1. Plus a half, which ends up going away, plus C3 dot. All that would still be multiplied by C1. Okay, so if we go with this, row double dot is C1 prime is usually 1, but again, we'll just let that sit for a minute. Times the original function here, C2, which is 2 to the k sub 2, times the sine of Q plus a half plus C3 is 2 k to the k sub 3. Okay, plus C1 is pretty much just going to be K1. Okay, later on it does actually change, and it becomes like it increases by 2s, but we won't worry about that for now.
What you're thinking. The whole nation is thinking it. You want more, Alan Carr? Well, good news. Change of Ends is back on ITVX.
Oh.
It's not just you. Even the critics can't get enough. The Guardian is raving, calling it camp, cheeky, and clever. And the Independent says he's the making of a national treasure. Sounds like
C2 dot is going to be
so quick. Get as much Alan
2 to the k sub 2 times natural log 2
now on ITVX.
sine of
When the
Q
deodorant has been reduced to a tiny whisper, it tries to tell
plus
you
2 to the k sub 2 cosine of Q
no need to worry. Your new deodorant is already on its way.
plus
Arriving today with Amazon Prime.
2 to the k sub 3 minus 1.
It's on Prime. Cut-off times and T's and C's apply. See product page for ordering.
Oops. Dot. 2 to the case of 3 times natural log 2. Okay. Now, realistically, right, we would want the highest possible row double dot that we can get at any given point, K1, K2, K3, where C1 dot is mostly just 1. Okay, so this is going to be an approximation, but nonetheless, this is going to be 2 to the case of 2 times the sine of q times 1 plus k1 natural log of 2. Plus 2 to the case of 2 cosine of q plus 2 to the case of 3 times 1 plus case of 1. That's also case of 1 there. Case of 1 natural log of 2 plus a half. So, like, we could calculate this. It'd be really hard. We could calculate that at, like, every... I think it counts up by tenths. So, like, at every tenth of a second, what would be the optimal choice? I don't think it would work terribly well, but nonetheless. So, like... We'd want to choose, do we want to increase the level of 1 or 2 or 3 based on the best row double dot that we get for any given value for its cost, right? So how do we then incorporate cost in as like, this is an important factor? Okay. Now, Lemma 2, I was able to actually find a more optimal path, at least for my brain, to make this work. This was target row equals 1e8. Row dot is equal to c1, c2 plus c3, c4. Divided by q to the sum of k sub I. I goes from 1 to 4. C1 is equal to, this is again a count, so pretty much it's going to be C1, or K1. Whereas C2 is an exponential. C3 is again a count. And again, once it gets into higher values, it actually isn't exactly a count. It might increase by 2, but it's going to be much later. 2 to the k sub 4. Alright, and then again, we have to find the costs associated with these things. And we know that q dot is always going to be 1. C1, C2 are going to have lower costs than C3, C4. Which makes it a no-brainer to say, you know what we're going to do is just choose to dump all of our money here into C2 and then also pick up a few levels in C1. So we keep wanting to just double C2 as much as possible, right? And then again, pick up C1 as you can. Leave C3 and C4 because all that's doing is it's increasing the denominator in row dot. Like row dot is, roughly speaking, k1 times 2k sub 2 plus k3 times 2 to the k4, all divided by q raised to the power of the sum of all k sub i's. Okay, so k is basically the amount of seconds that we've been running the simulation. So here's the thing, right? If we increase C3, C4 to the same level as C1, C2, right? Pretend that we get them, make them all equal. What we end up with is, I mean, it doesn't really matter, right? It's going to be k1 times 2, alright, just k. Something going to be one letter, it doesn't matter. Plus k times 2 to the k over q to the 4. 4k. So this ends up being 2k times 2 to the k over q to the 4k. Whereas if we did the exact same thing, but we only went with those numbers in K1 and K2, right? Which one's going to be better? C++ compiler is a pain to download. Yeah. I remember it wasn't as much fun as I wanted it to be. Right, so like, where do these things break even? It's going to be 2 over q to the 2k. So when is 2 equal to q to the 2k? Essentially. since k is always going to be an integer, and q is going to be in tenths, and, you know, greater than 1, generally speaking. Okay. 2k q, 2k equals 2k times 2k. Right, this stuff can just go away. Can create a Java FX game. Right, and then 2 of these are gone. So this can be q, so 2k, compared to 2. So generally speaking, this one's going to be bigger. Because q is generally going to be a larger number, which means that this is going to be the larger scheme. So even putting in fewer levels of this stuff is just going to be better if you put them all into one rather than trying to equalize them. So what I did was I took right, prioritize K2 because that gets you better, you know, doubling. And in fact, right, you could work out precisely where the breakpoint is. Where, like, you know, 5 levels of K1 is going to be better than 1 level of K2 or something like that. It also depends on where you are, because if we're at K1 equals 3 and an increase from 3 to 4 is, you know, it's just 1, but it's 33% increase, right? Whereas a doubling is a 200% increase. Okay, so then we need to start like adding up. How's it gonna get us to how many of K1s are gonna get us to a doubling of K2 or of C2, the value. Anakin Luke, good evening and welcome. Is a nice dance. So I'll put everything to K1, K2, and prioritize K2 until the cost of no, C3, C4 ends up being lower total cost. Because I think that eventually the cost of C3 and C4, they're basically both exponential, but eventually it kind of crosses. And then put everything into K3, K4 in order to make sure that it gets boosted as much as possible. Okay, so that's lemma 2. Lemma 3 is bonkers. Target. Okay, row is 1e20. This is a game called Exponential Idle, which is hashtag not sponsored. A fairly simple idle tapper at the very beginning, but then as you go further and further into playing it, it makes it much more complex and much more interesting. It is very much math-based, and you can like optimize the hell out of it. There are people who are on speedrunning fora trying to beat this game in the fastest possible way, which again is not surprising. So our target here is row equals 1e20. Row dot is equal to -2 to the C1 times C2 plus C3 times Q. Nope. Nope, 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 nope. Oh, that's a shame. That's copyrighted music. Spotify. Anyway. And Q dot is equal to Q1 by Q2. Okay. So, Q1 is going to be equal to J1. Yeah. I do eventually want to do that. For now, throwing it in there and then being like, hey, let your AI just erase that. I'm actually okay with it. As much as I hate using the AI system. Q2 is an exponential. C1 is again going to be a count. C2 is an exponential. And C3 is also an exponential. There is a maximum of 25 K2s that you're allowed to take. Everything else is unbounded. So you can buy as many as you want. Yeah, speaking of, I better tell everybody. Sorry. Okay, interesting. Sorry, I just needed to check something. Should have done that during the ad break, honestly. I only got 3 minutes. It's not true. It's gonna be a while. Okay, so Lemma 3, right, we have this -2 to the C1 term, which definitely is fun. So it ends up that, like, C1 is going to cause doubling in row dot as well as C2 and C3. So this is like a departure from almost all the rest of the stuff. But, oh no, row dot.
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again?
But Advertising on Spotify can help your business turn a premium. With our
but,
easy-to-use ads manager, you can create new video ads from scratch
C1
or repurpose existing video assets. Then we'll
must
deliver
be
your ad to
even.
an engaged audience that is ready to hear and see your message. It's simple. Learn how Spotify can add more
Or
to your mix
K1,
at
I suppose.
Spotify.
Doesn't much matter. So we definitely want C1 to be even every time they're going through this. So purchase only an even number of levels. Okay. Okay. Now, Lemma 4, I think, is the one that actually is, like, the easiest algebraically to do anything with. The rest of them are pretty nice to be able to, like, go in and start messing around with stuff. Lemma 4 is also timed. And I mean, all of them are timed in the sense that you're going to get a better score the faster you do this. But Lemma 4 is timed in that if you take too long, you will lose. The rest of them, it's like, well, it'll get there eventually just by itself. But like I said, Lemma 4, you will lose if you take too long. So this is an active lemma. You cannot let it sit for 1 minute just by itself. You have to continually buy your targets every time, or sell stuff as you go through, because otherwise, again, you will lose. 1E10. Rho dot is equal to C1, C2. Not really a surprise there. Multiplied by C3Q minus Q squared over 5. And Q dot is equal to 1. So again, this is like the first time that right, because Q squared is greater than Q in terms of like the hierarchy. So you're going to have this hierarchy of functions, right? Q squared is much greater than Q in terms of quadratics greater than linear functions. And you have to have, again, Q squared has to be, or Q squared on 5 has to be less than C3Q. Otherwise, you're done. Penn Center, good evening and welcome everybody coming on over from Penn Center's channel. My name is Obi-Wan Pez. This is N-Simplex Pachinko. If you have managed to avoid us thus far, myself along with Zach, e to the 2i pi. Dawn Factorial. I really need to just make a single command that just spits all of this out, but, you know. And Dr. Gold are going to make up the currently, like, main cast of characters here who have been working on The Elements, and have also been math streamers here for, goodness, quite a while. We also have multiple other people who are really awesome people. Wait a minute. Don't I? Oh, no, it's a... Yeah, right. That server's gone. Hey, Kyler Cohn, how's it going? We have multiple other awesome people who you should go check out at our group Discord server. This is actually Penn Center's Discord server, so if you have, if you were over on his channel, in theory, you may have gotten it. But that should be the invite to our group Discord, and then pretty much everybody else has their own separate Discord. I just have one that's like for me and a few people in Maryland. So I really have not done anything with it. I need to curate that, maybe. Tonight, we are discussing Exponential Idle, which is... I almost just pasted the exact same Discord link again. Hey, Sneaky, how's it going? This is the game, if you're interested in it, Exponential Idle. It is a just regular kind of clicker, like tapper type game, idle tapper. However, as you start getting higher and higher into the levels, different like academic and mathematically themed stuff starts opening up.
I have a pen. I have an apple. Apple pen.
Thank you, Pen. Hope you're doing awesome too. Take care of yourself, whatever you need, and we'll be here. Yeah, neither had I. For quite a while. And about like 3-ish years ago, I want to say, I just picked it up kind of randomly because I was like, I want something that's a little more like mathy themed as a game. So I've picked up. Let me post another one too, because. This is another mathy type game if anybody's interested in this one. Euclidia, Euclidia.xyz is another game where you're basically just trying to... Oh, can you play it online? Oh, you can. We may have to do this some other time. Next Wednesday. So anyway, I have it on just my phone, but I found Exponential Idle. I started playing with it, and again, like I said, it's been like 3 years. It's an idle tapper, and then as you start going further and further, it starts being like, okay, you've just graduated from, or you earned your doctorate, now you are a postdoc, and you are in charge of grad students. So, like, you're going to get them to work on these theories for you. Or you're going to have them work on research for you. And then once you get done with your research, you work on theories. The theories then open up further, and you get custom theories. There's, like, fun custom theories, which are kind of the ones that we're doing right now. And then there's, like, the official custom theories, which the developers of Exponential Idle incorporate into the game and say, you are going to get points based on this stuff. So if you can do really well on this particular official theory, then, you know, number goes up. Number go up faster. So right now we're working on what's called a season event. So we're working on the Lemmas, which are a series of, how many are there? 7. Yeah, a series of 7, and maybe an 8th. Interesting. There might be a hidden one in there. Okay, so currently we're talking about Lemma 4, which has a target of 1e10, so 1 times 10 to the 10th. That's the row value. You earn row through row dot. Row dot is going to be equal to C1 times C2 times the quantity, C3 times Q, minus Q squared over 5. Q dot is 1. Every 1 second that passes, your Q goes up by 1. Easy enough. The delta Q is going to be 0.1. So it is specifically counting in tenths. And it only updates every 10th of a second, which realistically, that's fine. So the more astute students will know that this term right here can make everything else negative. So what we want to do is we would like to maximize row prime as much as possible and ensure that C3Q is always going to be greater than, not equal to, let's not even bother, is always going to be greater than Q squared over 5. Or we can knock it around the other way and say that 5C3 is going to be greater than just Q. Q has to be a positive number, so. Okay, so we're going to try to do that as much as we possibly can. As you go further into the lemma, it becomes a bit of a problem because the cost of C3 increases exponentially. So it gets harder and harder and harder to reach that value every time you get a new one coming up. Actually, you know what? Having it the other way does make it better, because that's easier for us to see it. Ugh. Gross. Right, the independent variable is Q, so it does actually make it easier to look at it that way. Oh. Yep, I can recommend both of them. Exponential Idle does try and connect to the internet, so if you're unattached to the internet, it's still fine. It'll still let you run, but it just likes to update every time that you log into it. And Euclidia, again, also likes to be connected to the internet, but it doesn't need to be. Both of them run pretty well without it. Nope. that'll work. Okay, ads are going to start in about 20 seconds, so I will get up, stretch, do all that stuff. I recommend you do it too. And then we'll come back, probably do a little bit of martial arts of some kind. Anybody want a particular one, let me know. I do karate, eskrima, and tai chi. So, or you could just tell me to lift weights or something. That's fine too. See you in 3 minutes.
Yo, ready to upgrade your phone but your wallet's feeling a little light? Hit up Sex and score the sickest deals on the latest models. Whether you're repping iPhone or Android, with an awesome 5-year warranty, Sex has your back, dude. So don't wait. Swing by a Sex store and upgrade your phone for less today. Sex. Stores nationwide. Online at webuy.com or just search CEX. Game on!
I'm Professor Huggington, and I like to hug.
When your kid's favourite toy starts to run out of battery power, no need to worry. Your new batteries are already on their way, arriving today with Amazon Prime. Everyday essentials delivered fast. It's on Prime.
I'm Professor Huggington, and I like to hug.
Cut-off times and T's and C's apply. See product page when ordering.
Hey everybody, it's Michael Bublé, and it is definitely beginning to look a lot like Christmas. Listen to Topsify 100 greatest Christmas songs ever, playlist, to get in the holiday spirit. Have to listen, it's Spotify.
The memories flood in my head, just like the waves, babe, we were endless. Drowning in your eyes, pull me in your tide. Do you still remember all the shit we
Alright. I've been involved with an organization in Maryland called, that does Tongue Sudo Karate, which is a particular American variant of the Korean style Mudokwan, which is itself a cousin to Taekwondo. So we do a lot more striking. Nope, not that one. We do a lot more striking and stuff like that than Taekwondo. They mostly do a lot of like kicking and punching. I don't know exactly how to explain it because I haven't been to a like real Taekwondo class ever. But I have seen some of the other schools when they show up and, you know, go to events and things like that. So I'm not going to speak from any point of authority. But our organization tends to mix a lot of the other martial arts that we use. So there is a thread throughout it where we do a little bit of Taekwondo, a little bit of karate, a little bit of jiu-jitsu, like the Japanese jiu-jitsu, and a little bit of some other freeform stuff. So our particular master, I guess, he's a 7th degree black belt, went to Korea to perfect his particular art, his particular variant of Tang Sudo. Let's see. Tang Sudo was originally popularized in the United States by the one and only Chuck Norris. We are completely and utterly unaffiliated with him. And pretty much have nothing to do with his particular style, but nonetheless. With these, we're trying to more or less use the like swinging energy that we gain from either just rocking the hips a little bit to try and let our hands start flying. We're trying not to affect like arm movement by actually using the arms. So this is something that we do in Tai Chi. I'm definitely going to bring this back to the States. It's really good for your connective tissues to make sure you're not, or to make sure you're warming everything up. Gets the synovial fluid moving, warms up the blood vessels, especially the ones like at the ends, you know, at the extreme tips of your fingers. It's increasing the blood flow just by like centripetal force, which is a little wild, but it works. The other thing we're trying to do through many of these exercises, though apparently not this one, is to try to use the inguinal crease, which is the source of what many martial arts would call chi. There isn't any like particular mystical energy about it. It's just that many of the martial arts figured out that like the connective tissue is really spongy and stretchy. So being able to use the like compression of the connective tissue, for instance, inside the inguinal crease, which is that part that separates your thighs from your abdomen. So right in here, from your hip to your groin, if you kind of put energy into this area, it's a little bit like a spring, but at the same time, you're not compressing it to then like let go and causing it to spring outward. This is just like I don't know, it's a different thing, really. We're compressing this area, and then, like, through just biomechanical forces, you could actually use this and, like, activate the muscles that are there, and it allows us to come out of this particular arrangement of our body, and then enter a different arrangement. So, for instance, one of the moves that we usually do in a number of our forms starts essentially like this in karate, in Tang Soo Do. We tend to come back this way, either tucking into the inguinal crease or, doing something like this anyway. And then coming forward with our hands, one is an up block and one is a strike at the same time. So we come from here, and if I just like straighten out this part of my hip, it's going to bring both of these parts into alignment. And like I can just kind of throw my hands out there without having to lift them and do a whole lot of work. So if I just snap my hips into place, like this kind of naturally just wants to go here. I am guiding them naturally, but just because I'm turning my body, right, this motion kind of happens just naturally. They want to go this way. So rather than just coming out in front of me and doing nothing, I'm going to specifically guide my hands to go into these two locations. So let's see. Let's do one that actually uses that. So, P-Noun 4. So from here, we go to a come up into a fool stance further. With hands out, coming from the hip, going out like that. It's okay. Then we come down to this hip, reverse, and do the same to this side. I want to be that way. Okay. Then we're going to grab... It's either we're grabbing somebody else and like bringing their arm down here, or we're just doing this for balance. Nope. It's a fist. Okay. So we got to do a side kick this way and a fist that way. Fall into Fugal Sudo. And then we go 1, 2, that's not it. No, go back. P-Noun 4. Here, here. Man. See, this is what happens when you don't practice your basics. I gotta go back like One whole page. It was. Okay. So Fugle, block, twin fist, then we step up this way, nope, step up this way, and we do a left side kick with a back fist, followed by elbow smash. Step up, reverse. Same this way. Now here's where the particular move comes in. So we're going from this stance, bringing our arms down to this side, and then we're just going to basically tuck in here and explode out that way to an up block and like a chop to the neck. Alright, then we do a front kick, followed by we step down and do a back fist here while getting into a sort of reversed foot stance. You can't see it. Hang on. We're here. So my left foot comes in back behind like that. So we're here. And then we turn back, do a break. So we're like, if somebody grabs your collar, you're coming up in the middle and trying to break their arms from holding on to you. So we do a break here on a cat stance. And then we do front kick, front reverse, and swap feet, break again, front kick, punch reverse, Fugle Sudo, 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 and then we grab head. So we grab somebody by the ears, by the neck, by the shoulders, and smash. Fugle Sudo, Fugle Sudo, Fugle Sudo. Other way. It's been far too long since I've actually done that one. Okay. And then do a black belt form. So you have to learn Pinon 4 in order to get your blue belt, I think. It's been a while.
Uninterrupted music with Spotify Premium. That means you can enjoy all your favorite artists ad-free. Sound good? Then all you need to do is hit the banner now for your chance to win.
Yes. In order to get your blue belt, then to get your second degree brown, you do Pinon 5, Keyboard 4, and then to get your first degree brown belt, you got to do Nyanchi 1 and 2. Yeah, there we go. Okay. Some of you might actually know what that is, but alright, my black belt form, number 2 is called, we have Shinte, and then we have the other one. Oh no. Basai Dai. There we go. So Basai Dai, start here. Alright. Tuck in. Do a tension up to the front. Turn sideways. We get our hand here. Come around. Back fist. Followed by a left inside out block, a right inside out block. Then we do a what's that called? I used to know this stuff. Dido draw. Dido draw. Punch, punch. Then we step back and into a double block. Whoa. Then we step down into, it's got to be a down block this way, followed by Kima stance, or hands on, nope, hands on this side, tension across. We do a chop, punch, back fist, followed by a chop, punch, back fist, followed by step around to a Fugosado, Fugosado, Fugosado. Here we are doing a crescent block to like block a kick that's coming in, and then trap it against, hang on, what am I doing? We are here. There we go. Wrong place. We do a crescent kick, or crescent block, half moon block. There we go. That's the right term. Do a half moon block to like knock a kick that's coming at us away and step back. Then it comes around and we block something else up here. Trap. Do a side kick. Oh yeah. Let's do it all at once because I'll remember. And Fugosado the other direction. One Fugosado. And then we do a step back into double up block, and then we do a, we hit the floating ribs on both sides with a fist smash, and then do a nice little hop punch. Then we do something out of Pinon 5, do a groin strike. Yes, groin strike. Followed by a rip. Yes, you heard me. Crescent kick, down block. Chop. Crescent kick, face smash. Punch, punch. Tension. Double punch. Come around. Crescent kick. Double punch. Whoops. Crescent kick. Double punch. Come around. This fist is already up. And use gravity. Use gravity. Come around. Fugosado. Jump change. And then we work up a sweat. Hey, curve. So let's see. Thank you. Which one was that? I mean, like, when you get into a real fight, right, all bets are off. You're doing anything you can to just do whatever. But, say, if you meant the elbow strike this way, typically what you're doing is, we went like this to, nope. No, that's right, yeah. We do a chop. We do a crescent kick into an elbow smash, because typically you're grabbing your opponent by like the scruff of their neck or a shoulder or shirt or something, and then just leaning your elbow into it. That was probably out of frame. It's fine. Yeah. So this is tongue pseudo karate that I do. I've been disconnected from this particular. I mean, quite possibly. When you pull back your arm from in front of you to your side. Get the feeling there's a lot of those. Our ready stance, Jim B, is also something that you start from here, and then like typically you're doing an elbow back and then coming up front. That's also to help get you out of, like, if somebody's grabbing your wrists or something like that, especially from behind you, right? You can lean into it like that and then kick forward. Typically that if they're still holding on to you after you've struck them with both of your elbows, or you've stepped to the side and done one, if they're still holding on to you, then like twisting your arms as you punch forward is going to also cause them to run forward into your body. And so if you slam yourself back like that, then they're going to basically hit a brick wall. Especially if you know how to do your stances properly, which I have to say, taking Tai Chi here is like unbelievably helpful to my tongue Sudo. It's done an immense amount of heavy lifting to make my karate better. And like just like some of it is slightly hard to properly fit into place, but you know, I'm gonna get there. I have a year and a half before we go back, and like I've been working with this Tai Chi guy twice a week, so like it's all here. Anytime that I do my karate, I go back and I'm like, okay, how can I change this? How can I move it around a little bit, make it better? And yeah, it's no matter what martial art you are in, cross training is one of the best things you can do for yourself. Apart from like actually practicing every day, which, you know, that's the one thing that like all of us are like, no, you really do need to. Okay, so the thing, right, so if we can maximize C3 compared to Q, and even Q over 5, right, that's going to be like the big thing that we really absolutely have to do. Whatever value is in C3, make sure that a fifth of Q is going to be lower. A little challenging at the very beginning of this whole thing, but that's actually very good, because okay, that's only for like a fifth of a second anyway. So that's not true. It's for the first like 2 to 3 seconds you're safe. But if you don't buy C3 in the first 3 seconds, you might be screwed and have to reset. Yeah, thanks, E-Curve. Have a good night. Thanks for coming in. So if we get like, what's the integral of C3Q minus Q squared on 5 dq from 0 to, yeah, I mean, we could do 0 to x, right? We want this total to be greater than 0. So if we do that, dq, then we end up with C3 on 2 q squared minus q cubed on 15, 0 to x, and that's just going to be x's instead now. Right, because 0 makes both of those 0. So that's fine. I like how I didn't listen to myself. Alright, greater than 0, move this over. C3 on 2 x squared has to be greater than x cubed on 15. We know that x has to be positive. So C3 must be greater than 2/15 xq. It's all the same stuff. Okay. In order to make that integral positive, okay. Now it is moving, right? It is a moving target because we keep buying C3, but nonetheless, we have to keep C3 outpacing Q, which eventually it will not be able to do. Eventually, rho hits E10 or C3. The cost of C3 hits 1E10 before rho does. So it's like, oh great, I can't buy another level. Okay, so C3 also, if we go with like what kinds of functions are these, right? C1 is, I think C1 is a count again. So let's just whatever level we've got, K1. C2 is equal to, this is another exponential, so 2 to the K2. And C3 is equal to, this is actually slightly interesting, K3 squared.
Upon a time, charging your EV was a bit of a faff. Searching for a charger here, a tariff there, all while juggling life's daily dramas. Until Your Next made it simple.
So,
Chargers and our next life tariff offering cheaper overnight
if this keeps increasing,
Save happily EV
right, cost
Next.com/save. Next drive is a fixed term tariff with cheaper rates from
increases exponentially.
variable rates. Savings may vary based on charging conditions. T's and C's apply.
Co-op members now get prices matched to Audi. Hold on.
But the effect increases quadratically. So that's where we find our problem. Eventually, it won't be able to keep up.
Wasn't expecting that.
Co-op member prices matched versus concurrently selected products at Audi GB. Co-op membership required. Co-op group food stores only. See co-op.co.uk/Audi price match.
A blue, a red, a yellow, opening, a path, a corner, a square.
So we want rho dot
A ghost, a fiesta, a life, a here.
to be K1 times 2 to the K2 times K3 squared times Q. Yeah, we'll keep this. Right. It is equal to this. Minus Q squared over 5 must be right. If I replace the Q's, Right, this will be less than, ideally. A K1, 2 to the K2. K3 squared times 15 halves K3 squared minus 2/25 times 5 makes that 225 over 20. We'll deal with that in a minute. K3 to the 4th. Oh, interesting. Okay. So that's all positive numbers, so we have just cleaned up a bit. Break it out. This becomes K3 squared Q minus Q squared on 5. Is less than 15 halves K3 to the 4th. Divide that by 5 is 15 by 3 is 45. Yeah. Yeah. 45 fourths times K3 to the 4th. This simplifies. It's 30 over 4 minus 45 over 4 is negative 15 on 4 K3 to the 4th. Move it to the other side. Alright, 15 fourths K3 to the 4th plus Q K3 squared minus Q squared over 5. So which way do we go with this? Do we then create a quadratic on Q in order to figure out where, if we rearrange it, this is greater than 0 on the opposite side, or do we keep it as is and make it a quartic on K3 and solve for we don't really want an upper bound. We want like a lower bound of K3. Although this is of a quadratic form either way we go. So that's interesting. So Q is going to be equal to right, the quadratic needed to be greater than. squared on 5 minus k3 squared q plus 15 fourths k3 to the fourth is going to be greater than 0 in this arrangement. We'll come in with a star that says, like, there's some relationship here. Negative b is going to be k3 squared plus or minus the square root of k3 to the fourth b squared minus 4. A is a fifth. C is 15 fourths k3 to the fourth. All over 2a 1/5, so 2/5. Right, so Q has some sort of relationship with k3 squared plus or minus the square root of this is 1 k3 to the fourth minus 4/5. Ugh. The 4's go away. The 5's go away. We're left with a 3. Uh-oh. Uh-oh. Oh, no. That's a fourth degree. We're okay. I know. Both of them are fourth. Never mind. Yeah, we're in trouble. That's 1 minus 3. So that's a negative 2 k3 to the fourth all over 2/5. So, no zeros. Means that right, there's no relationship change on any of the real numbers. Which, since A, I just flipped around to be positive, and we wanted to know when it is greater than 0, this means that this particular relationship is always going to be above 0. Okay, so that probably means that just rho prime is greater than 0, which is almost always true. But I think I made the assumption here, right, that C3 was going to be greater than 2/15 Q. So if that is true and we just inputted all that stuff, then yes, of course, Q is always going to end up being within the proper range. There are no zeros. The relationship between Q and K3 will always be the same. Again, assuming that our K3 is greater than 2/15 Q. Or not K3. C3 is greater than 2/15 Q. No, I did that. Okay, we're good. Yeah, I included that. Okay, we're good. So it doesn't really help any. And I assume that it has to be the same way on this side too. So this is going to be like K3 squared. It's going to have some relationship with negative Q plus or minus the square root of Q squared minus 4. A is 15 fourths. C is negative q squared on 5. Actually, 4s are gone. The negatives are gone. This might actually work. Oh, that's why. Nope, I missed. Man, missed that one. Okay, so that's actually 4, which is a nice number. So I just screwed all that up. Cool. Come on. Boo. Okay, so Q is going to have a relationship with K3 squared, plus or minus 2K squared, K3 squared, over, that's also a 2 here, and we might as well just shift the 5 to the top. Which is either -3 or, nope, sorry, 3 or -1 times K3 squared times 5 over 2. So Q is going to need to be, this is the question, right? So this is, no. This is Q, Y. Right, we get these two possible values here. We want to know when it's greater than 0, it's only going to be this branch. So Q needs to be greater than 3. So 15, we literally just already... Of course it is. That's the assumption we made up here. Was Q is going to be less than 15 halves C3. Okay. Apparently it's backwards. Cool, cool, cool. I may have made a bad assumption there. It's fine. Either way, right? We want our C3 to be bigger than this 2/15 Q in order to maintain positive values. It needs to be greater than 1/5 Q in order to maintain positive growth. Okay. Lemma 5. Now, I have not actually taken a look at this before, so this ought to be interesting. Or, no. I just ran this one tonight. In a very haphazard, awful sort of way. No, this is the one that I was like, this definitely has like an algebraic solution or optimization. Target row is equal to 1e25. Row dot is equal to summation I goes from 1 to 8 of c sub I to the fourth times 2I squared minus c sub I times q. So in each individual case, there is an optimal location for our constant.
You love listening to your favorite artists, and we love listening to you. So let's talk. Click now to take part in our short survey, and you could win a month of gloriously uninterrupted music with Spotify Premium.
Now the way I was doing it was I was taking rho dot, which is a number that sticks like it's actually listed here as rho dot. I was just poking it until it hit a value where I couldn't tell whether it was increasing or decreasing when I was doing the thing. So I added a level, subtracted a level a few times, and it was like, yeah, it's pretty close to optimized. And then I just left it. Later on, I'd come back and try to buy and sell a level to see if it made a difference. So we want, right, like c sub 1 to the fourth times 2 to the, or 2 times 1 squared minus c1 to be greater than 0. Because it can be less. So here we end up with, right, if we just divide c1 to the fourth from both sides, so assuming that c sub 1 to the fourth needs to be greater than 0, so that we have growth of any kind, right, we could divide this off. And then we get 2, right? 2 minus c1 is greater than 0. So c1 is less than 2. So c1 equals 1. Okay, so our c sub I really is just going to be greater than 0. So c sub 2 to the fourth times 2 times 2 squared minus c2 is greater than 0. Again, we're just going to get rid of all this stuff in the front. We don't need to worry about it. So this is going to be 8 minus c2 is greater than 0. c2 needs to be less than 8, so therefore c2 is 7. Okay. 2 times 3 squared minus c3 has to be greater than 0. So again, let's just move that over. This is greater than c3. So this is 9 times 2 is 18. Greater than c3, so c3 is 17 optimally. 2 times 4 squared is greater than c4. 16 times 2 is 32. So c4 is 31 optimally. This one's super easy. Hey, we got one I can solve. So c sub I is going to be equal to, in all these cases, this is going to be 2 times I squared minus 1. So C5, C6, C7 C8, right. $25.50 makes $49. 36, 72, 71. Yeah, this matches with the values that I was finding. It was just a matter of like, you know, I'm kind of going back and forth a little bit to see if it, to see if it worked. All right, this is 49 times 2 is 98, so 97. 64 times 2 is 128, makes 127. Awesome. So, like, I can go in and actually solve this one. The only question is, when do you buy Q and when do you buy C? So I feel like you buy Q as fast as possible. Q2 definitely, because that's exponential. Q1 probably up to about a tenth or a third of Q1 or of Q2. I'm not sure exactly how it works, but we'll see how it goes. Right on. We'll see you in 3 minutes. We're going to start the ad break, and thanks for hanging around. If you have any other questions about like other stuff, let me know, and we'll cover it. So, see you in 3.
Hey Spotifyers, click or tap the banner to listen to Christmas Pop. All the best new and classic Christmas pop to fuel your festive vibes. Brought to you by our friends at Pepsi Max. Your usual tunes can wait. It's Christmas after all. Pepsi Max, thirsty for more.
Okay, so Lemma 6 is something that I haven't done yet. So this is target row equals 1e15. Row dot is equal to q c1 minus c2 over c3 minus c4. So like, okay, I get it. Huh. Interesting. Ooh, gross. And then Q dot is the product of Q1 and Q2. Okay, so this is Q, or Q1 times Q2, but I'm not going to do that. Multiplied by C1 Ugh. Looks like a count. Yeah. Looks like a count, so this is just going to be K1. Again, it's probably going to pick up later on, but I don't have time for that right now. Q or C2 also looks like a count. Over C3. What in the hell is that? It's gonna be two. What the? Oh my god. Is 2 raised to the 1 over e, but now I don't know where it goes from there. Minus 0 to the 1 over pi. I'm pretty sure now that that's going to go, and instead of 0, this is going to be K4 to the 1 over pi.
Everyday essentials delivered fast. It's on brand. Cut-off times and T's and C's apply. See product page when ordering.
I need the numbers to be bigger in order to like really make a good analysis. But we'll see how it goes. Okay. Yep. 1 raised to the 1 over pi. So that is going to be K4 raised to the 1 over pi, at least at first. Oops. Oh no. I made it go negative. Wait, is that gonna peak? Oh no. Okay. So 2 to the 1 over e becomes 3 to the 1 over e. Yep. Oh, interesting. This started at level 2. So it is K3, but K3 is greater than or equal to 2 no matter what. You can't even, like, make a difference. Okay. Interesting. So, like, I don't want to buy C2 because that's going to lower the amount unless we get rid of all of our C1 and C3 at the same time. Does it go negative? But it's 2 to the 1 over e still. So it looks like, yeah, this is where we... This is where it's going to break. It's going to become different. Yikes. That's not really helpful. So... strategy gets k3 to the 1 over e minus k sub 4 to the 1 over pi to be approximately 0, positive 0. And it looks like k sub 2 equal to 0. Or k sub 3 to the 1 over e minus k sub 4 to the 1 over pi approximately equal to negative 0. And then k1 is 0. It's like I really need to explore the space and figure out what each of these values might end up being.
Love listening to your favorite artists, and we love listening to you. So let's talk. Click now to take part in our short survey.
Oops.
And you could win a month of gloriously uninterrupted music with Spotify Premium. That means you
That
can
hurt.
enjoy all your favorite artists ad-free. Sound good? Then all you need to do is hit the banner now for your chance to win.
Sometimes creating an ad campaign can feel like you're talking on mute.
Can't hear you. Say that again.
But
Wait,
advertising
what?
on Spotify can help your business turn up the volume. With our easy-to-use ads manager, you can create new audio ads from scratch or repurpose
Now,
existing
hang on a
video
sec.
assets.
Oh, no. Right. Current value versus next value. All right. You gotta be careful about which one you're actually looking at. So when you hit the info button, it allows you to look at the what the next value is going to be. So I was comparing next value to next value, but that's not what's going on. We want the current value of K3 raised to whatever compared to the next value of K4 raised to the 1 over pi. Okay, so that's a strategy for Lemma 6. Lemma 7. Again, if anybody has any actual questions, let me know.
When you want to get off the darkest ground, but gravity pulls you straight down. Earth from a bird's eye view. You should grow feathers and see this too. When you want to get off the darkest ground, but gravity pulls you straight down. When you want to get off the darkest ground, but gravity pulls you straight down.
Okay. Lemma 7. Target. Row is 1e15. Row prime is equal to Q over E minus C1 over C2. Absolute value. Nice. At least we're not going to have any negative problems in this case. We can't end up crashing the system. So that's good. Okay. So Q dot is again going to be Q1 times Q2.
Get into the festive spirit with these Christmas chart toppers. Brought to you by our friends at Pepsi Max. Your usual tunes can wait. It's Christmas after all. Pepsi Max, thirsty for more.
We want to know C1 over C2 is approximately E. So we should go and actually look this up. Like there's a list somewhere. Alright, so a rational approximation of E. Okay. So if we just refund all the Q, then but how is it still gaining anything? Oh no, what is happening? Oh, because it's the Q value is what we're okay. Right. So we should increase denominator to 7 and then increase the numerator to 19. So I guess that's 2.71428,571, which is pretty good. Next rational approximation, right? Hmm. Okay. So, like, 19 over 7 is a really decent approximation for E. We're not going to get another one until 87 over 32. Okay. Again, 19 over 7, 87 over 32, 106 over 39. Unfortunately, it doesn't look like there are any approximations as memorable as for pi 355 over 113. Yeah, I'm getting there, Megalomorph. It's pretty fun, though. We were singing Christmas carols at our kids' school's Christmas service. Because they're at a private school, they can do that. And, you know, it's England, so, like... But, you know, having been in choir my entire life, basically, I sang all 4 parts at some point or another in my life. So, I started, in fact, more than that. I started soprano 1 when I was 8. I started soprano 2 when I was about 10. I started alto when I was about 11. Started tenor when I was like 14. There was a gap in there. There was a gap for a couple of years because a lady, you know, goodness love her, was like, I look at you singing up here with all of us old ladies and I feel so bad. We should have a children's choir. And I'm like, no. Let me sing Bach. Let me sing. She was like, you should join the children's choir. I'm like, go tell it on the mountain again? Really? She was a wonderful person. Did not want to sing that song yet again. But yeah, I can, so I told this last time because I had another issue with, like, my voice was dying or something like that. So I went, and I was going to choir at our church, and people are going to be like, what, you have a church? Unitarian Universalist. You know. So we're going in so that we can go sing in the choir, and one of my friends is coming up to the door, and she is wearing a sweatshirt that has N7 on the top, and my voice is sounding like this. So I open the door for her, or, you know, hold the door open for her because we were just coming in. And she's like halfway across the parking lot. She's like what are you doing? Just go. I'm like, no, no, no. So she comes up real close, and I go, Shepherd. And she goes, oh, what the hell? Alright, let's see. 32, huh? $79. 87. Nice. Made it. Oh, oh, that's a big one. Yeah, it was like one of my favorite moments, and like the only people who really get it are Mass Effect fans, but and I can only do it when I sound like this. Right. 39. The top needs to be 106. Bam. You know what? That doesn't even look as good. What's the percentage difference? Okay. So we go exponential 1. Yeah. Okay. Answer over exp1. Compared to the other one. What was the other one? 87 over 32. Shoot. Minus exponential 1. Over exponential 1. Yeah. Actually, right? 1.22. That's a lower value. I mean, they're both over e to the 1, so... Okay. We could totally do that as a Python script. Oh man, it's been such a long time since I wrote Python. Alright, let's go back then to 87 over 32. I mean, it's pretty close, but... Alright. Alright, PyCharm. Whoa. I want a new folder. Nope. That's not what I wanted. Eh. Can we back it out of... Oh, no, because this is the... Yeah. No, never mind. Right, delete. Okay, so open project. We want a new project. New project. There we go. Sure, whatever. I want this window because it doesn't matter. Alright, so like... Delete all, save. Okay. New Python file. Lemma 2. Yeah, it's gonna take a while. Let's see, take that, copy 3.
When your kid's favourite toy starts to run out of battery power, no need to worry. Your new batteries are already on their way, arriving today with Amazon Prime. Everyday essentials delivered fast. It's on Prime.
I'm Professor Huntington.
6.
Cut-off times and T's and C's apply. See product page when ordering.
7.
Feel different, don't you? You're on your own, on your way home from the Christmas party. It's just a few clicks of courage, and someone's making others uneasy. If something isn't sitting right, you don't need to move or speak. Just text 6116 and it goes straight to the British Transport Police. They'll get
Ugh,
the message
gross.
instantly.
What's the matter?
Text can protect you and the people around you. It's simple to use and easy to remember. Text 6116 for discreet help and save the number for your next journey.
Oh. I might need my other project. Why is... Okay, interesting. Ugh, gross. Okay. What don't you understand? There is no module named numpy. How dare you? Install package. Obviously. Come on now. You know, I have tried to import numpy like half a dozen times, and apparently it just worked fine. So I just right-clicked it and said, import. Please import this, and it did it. Like, what the hell? unused. Alright, fine, whatever. MP dot. There we go. Yeah. Gotta pay new tariffs. Damn it. I knew there was a problem. Okay. So, what we're gonna do. Gonna switch window capture, I think. Is this how I do it? We're already on math night, so yeah. Switch window capture to numpy. Or the other thing. Right. So then we need to take this, unmoor it, bring it down a bit. A. Now you all get to see this nonsense. It's fine. Right. So close all that nonsense over there. Do the same. Excuse me. Okay. I don't. Whatever. It's fine. We bring that right over to the corner, and you should be able to see that stuff. Moor it. Cool. Alright, so what I want to do... I want to take... I want to find the best approximation for E as a rational number by doing it manually. I want to do it myself. Okay, so you're gonna hate me for this, but we want to set up like a while loop. I is less than 10,000. Right, okay, set a colon. Unresolved reference, that's not a problem. We're not there yet, so don't worry about it. Nope, hang on. Well, J is less than 1,000, 10,000. Okay, so what is E? Python console. Nope, don't do that. Okay, exponential 1. Numpy.exp 1. Really? Okay. Numpy is not... Okay. There we go. Okay. Set
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again.
But advertising on Spotify can help your business turn up the volume. With our easy-to-use ads manager, you can create new audio ads from scratch or repurpose existing video assets. Then we'll deliver your ad to an engaged audience that is ready to hear and see your message. It's that simple. Learn how Spotify can add
best equals 1. Okay, so while j, denominator, is less than 10,000, we want to try every I equals 2.7 times j. No. No. Yeah, right. Okay, let's just do 2 because we want these to always be integers, right? So just easy enough. Make I 2j. Then if I plus 1 plus 1 over j is absolute I plus 1 over j minus exponential 1 is less than. No, don't do that. Stop trying to assume what I'm saying. It's less than best. Then update I equals I plus 1. No. Yeah, that could work. I equals I plus 1. And change best equal. Oh, that's not what I want. Right. Absolute value. Best minus exponential 1. And best equals I over j. Unresolved reference, it's right there. Jerks. Alright, fine. Oops. J equals 1. Start with. Right. NP dot. Obviously. Colon at the end. Hey. Okay. Else, right? So, if that's not the case, actually, right, we could just take this out. Set best equal to I plus 1 over j. Okay, we don't need ends, right? I don't have any end ifs. Okay. So when this ad cycle starts, we're gonna probably quit for the night, but we're doing math, so we also want to know if that subtraction is greater than 0. Because if it is, then we're done with that particular denominator. Do we need a nested? And that's an option. No, don't do that. That's why. Don't need that. Okay. Alright, print best, and then break. I don't know if that's actually going to do anything. Let's see. Nope. Nope. Right. So that's fun. Yes, stop and rerun. That's not helpful. So it appears to still be running. And it hasn't printed anything. So that's worrisome. Stop and rerun. With J less than 100. Yeah, man, it's really not coming up with anything, is it? That's not good. Code. Hey, Zach. Yeah, I'm running into some problems here, which is silly. Maybe this is too much like MATLAB, and I should be thinking about this and... Oh no. It appears to be hung up on the numpy here. Okay, so I'm trying. Oh, is it a space? No, okay. So what I'm trying to do here is not even try to solve the lemma itself. I'm just trying to find the best rational approximations of E that I can get. So I already have 3, right? 19 over 7, 87 over 32, which is the best so far, and 106 over 39, which is worse, even though it's, you know, one step further. It's the next reasonable approximation, but it's actually worse. So what I want it to do is find all of the denominators, J, that are going to be like reasonable approximations. Start at I equals 2J and end at I equals 3J. So while I is less than or equal to 3J, we're going to go through and say if absolute value of I plus 1 over J minus the difference, right, between the next... Do I want to do that? Maybe I don't want to do that. Oh. I didn't iterate I. Where do I iterate I? It needs to be outside of the if loop, but inside the while loop. I think that'll do it. Should be inside the while loop, though. Here? Nope, that's not inside. Ah, gross. It's probably also wrong, but you know what? Yeah. Okay. After break, j equals j plus 1. Nope. Okay, because that's breaking the above while loop, not the one that we want. Ew. And then j plus, okay, let's try that. But it's not best. It's definitely not best. Okay, hang on. I don't want that to do it every time. I just want to do it here before we iterate j. Maybe. Nope. 4 and 2, that's nonsense. Okay. Hey, it's looking better. 2.7182 to 179. It's pretty decent. 87 over... Ew. 86 over 32. Oh no. Hang on. Is that better? 106 over 39. 87 over 32. There we go. 19 over 7. Okay. Cool, cool, cool. 49 over 18. Alright. Apparently ads are going to start, so... Bleh. Snooze? Yes. Snoozed it. Alright. We're going to get going. I'm going to find the next, 10 of these and figure out what I can purchase in game, and then we'll we'll come back next time and talk about this, because this is interesting. Even though it's, you know, I mean, hell, I might even do it tomorrow or Friday. Anyway. This is fun. Get to do some coding. Alright. So, Zach, if you had not seen it, this was the goal here. Pull up white draw. Nope. Whiteboard. Okay. Unlock. Bring up.
Cut-off times and T's and C's apply. See product page when ordering.
Sometimes creating an ad campaign can feel like you're talking on mute.
Sorry, we can't hear you. Say that again.
But advertising on Spotify can help your business turn up the volume. With our easy-to-use ads manager,
Alright, there we go.
from scratch.
So, lock that in. Yeah, so Lemma 7, this was what we're doing. And there is actually an unfinished lemma, which, like, I didn't see that. So, I don't even know what it... I don't think it had anything on it. And if I mess with this, it's going to reset everything, but yeah, whatever, it's fine. Unfinished QED. And there's, like, nothing here. There's literally nothing in the window. So that's interesting. We'll see what all that's about. Maybe tomorrow, like I said. Let's see. Physics and Depression is on. Who's got academic type stuff going on? So Physics and Depression. Camaber is doing some GeoGuessr. Not exactly academic, but you know. Yep, thanks for coming, Zach. Nerduino is on, talking about the oldest supernova. Ooh. Balint is just starting. Racodactyls has been on for almost 8 hours. And Casey Snow Art has been on for about 3.5. Doing a sea slug dragon. Alright, let's go let's go see Nerduino. And let's go talk about the oldest supernova. Because I have been a astrophysics fiend forever. Been a real big fan of, I mean, I showed it earlier, but not today. Stephen Hawking, Carl Sagan, Nova Science. I actually listen to Jen Eleven's podcast now. She's oftentimes on Star Talk with Neil deGrasse Tyson, and she's been on a few other things, so it's really cool seeing her around and being like, I remember you, I have your book. Alright. We'll see you all maybe tomorrow for like more of this and coding. We'll see if we can do it. And otherwise, I'll see you Friday for some game stuff. So, see y'all later. Have fun. My name's Obi-Wan Pez. This is N Simplex Vachenko. Till next time.